presentation. We're going to be talking about application solutions to network problems. Vigitron is a leader in the educational format for this. And what we like to do is to give you the education that will allow you to make the necessary decisions. The basic premise that we talk about is simple. Uh, Networking equipment, which has been around for a long time, was not specifically designed for our applications. So we're going to discuss the unique differences that are involved when we consider networking for security applications and what we do. Obviously, there is a lot to consider, and there's not everything we can cover in a half an hour. So as Michael alluded to, we have many educational presentations that cover individual aspects of all of this. And they are located on our YouTube channel, or we'll, at the end of this, we'll let you know how you can contact us for that information. So what are we going to talk about today? We're going to talk about the network differences and common differences. We're going to address problems. Many of you might relate to these problems, and we're going to discuss solutions for that and how we can solve them. A little bit of a commercial for those of you who don't know Vigitron. This is our 26th year in business. We're headquartered in the US. We have sales worldwide, and we work on the cooperation between you and us, both from a manufacturing standpoint and from a customer standpoint. And we'll go through this as we go through the presentation. Vigitron started life and still is primarily an engineering company. And in that time, after our first 3 years in business, we discovered a market in long distance transmission of video, data, and controls over twisted pair. And to date, we probably have about 800,000 channels operating worldwide, even though it's obvious that over the last 10 years, analog has succumbed to IP. So our analog division is about 10 years old. Here's the real key that's the difference. We design product by working with leading manufacturers in the field. We don't just sit around and come up with a great idea and think it's a great idea. We actually do about $100,000 a year of testing, interoperational testing with major manufacturers in IP cameras, access control, wireless, and LED lighting. And we then design equipment to bring out the best. Because after all, when you read a specification of a product, you're reading the specification of the product working by itself. The real key to the success of the system as a whole and the performance of that product is how does it perform on a network? So we have to design our products to bring out the best in that. And like I say, we have a huge database of exactly how these products work and what they need to do so. So let's talk about some of the common problems. And you might want to make notes or ask questions that we can address, but what are some of the common problems that we have? Well, we connect cameras and cameras don't power up. Sometimes a camera will power up and drop off the line immediately. Well, why do these things occur and how can we prevent them? The biggest problem that we find, I describe this way. An installer goes out and installs an IP system. It doesn't matter about how many cameras are involved or the size of the system itself. The next day, the owner of the facility comes in and notices that there are 2 cameras that are offline. They immediately assume I have 2 bad cameras. They call back to the dealer and they arrange to have the cameras sent in. 2 cameras are now gone from the system. The service department gets the cameras, does their analysis, and sends them back saying nothing's wrong with them. They go back into the system and the same thing happens. Well, why does this happen? This is what we found out in our very early analysis of doing an operational testing. As cameras grew up to adopt what we call accessory functions, such as you see here, such as day-night, LED, auto back focus, PTZ. These functions, when they start up, follow the rules of simple physics. And that's what networking is. It's simple physics. I'll give you an example. When you turn on a light in your room, the amount of power that's necessary to turn the light on is much greater than the operational power that's required to keep it operational. Same thing occurs with this. So when these accessory functions come into play, they require more power than the operation of it in its resting period. Now, I don't want to go into the details of PoE and how it works, but essentially this. If this, what we call the surge element, occurs for more than 40 milliseconds, or if the surge element requires more power than what the source, let's assume now we're talking cameras and we're talking the source being a PoE port, the IEEE standards involving PoE say, shut it down, I've got a short. And rather than destroy my power supply or destroy the connected product, I'm going to shut it down so that I don't damage anything. So what happens is the surge occurs. Why? Because we have day-night operation. We have LEDs turning on. We have all these things occurring during the night. It draws more power than the port of the switch because the port of the switch hasn't been taken into consideration as to how much power is really needed. Again, something we teach. And that's it. And it stays offline and it does not come back on. That is, except for Vigitron equipment. Sorry, but I've got to throw in those commercials. And so what happens? The customer rationally feels the camera is defective, but you get into this back and forth. Meanwhile, the customer is without a security system and you're in a fight with the manufacturer. Second thing is I have an installation, and this is becoming quite common because of the number of IP PoE installations. I've added new cameras to my installation and it shuts down. Why? Well, in that case, what I've done is I've exceeded the overall power of the source. Now, again, we're going to make an assumption here that the source of the PoE power is a network switch. Network switches can allocate PoE power in any of three areas. They can share the power, so that as I make additional connections to the network switch, the power at each port drops in order to affect the sharing. Another point is they can just stop providing PoE power. So when they get to the limit of PoE power, which is called the PoE budget, they just don't provide PoE power to any additional inputs. Or in higher level management switches, you can manage the PoE power by setting a specific amount to it. Believe it or not, there are no standards, IEEE standards within network switches that tell you how it's to be programmed. What's defined is what the PoE power is, 802.3 AT, AF, BT, etc., but not how it is. So any manufacturer, depending upon what the switch is, can provide and program their PoE switch in any different manner. The other point that we have is the cable itself. Now, cable is absolutely critical. The consideration of cable is absolutely critical in any IP installation. Now, why is that? Well, let's go back to the origins of PoE. When the first PoE standard 802.3 AF was devised, we talked about it in terms of a Cat5 cabling at a distance of 100 meters, 328 feet. So its ability to maintain the bandwidth and its ability to maintain PoE as far as what the resistance of that cable is and what the resulting PoE power is was based on Cat5 and later on Cat5e, Cat6, Cat6a. There were no standards that were ever set for coax or for single pair. Well, I started out by telling you that Vigitron made its career for many, many years in the single pair market. And single pair certainly is the basis of a lot of installations now, such as alarming, gates, etc. And also think about the amount of coax that's in the wall. Now, coax is really unique in the fact that it has a run out distance of about 750 feet, or about 2.5 times more than the 328-foot limit that we face in IP, in Ethernet connections. Coax and single pair share the commonality that they both are single pairs, but there are no standards involved. What's standard is that Cat5 cabling and what the signal is and the amount of signal that has to do in order for the source of the PoE to recognize the connected device and what we call turn on that device. Okay? Again, not to get too complicated about it, but if I take a camera out of the box, an IP camera, PoE camera, it's in the off position. If I program power to the port of a switch and I was to measure it, it would register as 0. Once again, it's those IEEE standards involved in PoE that says until I make that connection, nothing happens. Now, once I plug in that Ethernet cable, the first thing that happens is the source of the power, the port of the switch, issues a voltage. That voltage is called a detection pulse. It goes across the camera, that's called a PD, which is nothing more than a resistor. And for those of you with basic electronics, P equals E times I. The action of the voltage going across the resistance does two things. It reports back to the source of the power, and it says, I've got a valid connection, start transmitting power, and I need this much power. And as I related before in the surge area, if it requests more power than what the port can provide, nothing happens. If it doesn't go back and identify itself within about 40 milliseconds, it shuts down. So everything that was based on how PoE operates is based on the CAD5 cabling being able to maintain the proper connections and put out the proper voltages and receive and report that over CAD5 cabling. Well, how many installations out there do we have coax cable at 750 feet? And no standards were ever created. So when Vigitron got into the industry, the challenges were, when we talk about coax or single pair, we have to emulate all the things that allow it to function within the CAD5 world. But keep in mind that no standards were ever developed if we deal with it, if we were dealing with non-CAD cabling. What are some of the other common problems we face? And this is, I spoke before about the camera shutting down. This is probably the second biggest problem we get calls for, and we get a lot of manufacturers that will refer to our technical services as a result of it, even if Vigitron products aren't used. And that is, I'm looking at my NVR or I'm looking at my VMS system, and I saw a camera, the camera picture looks distorted, or I can't even see the camera. Why does that occur? Okay, what other problems involved? We're going to get into that. So what happens and why is my picture pixelated? Why did my camera disappear? And why all of a sudden does it reappear? I spoke before about one of the advantages about Vigitron products and what we do and what we've learned over the 10 years we've been in the industry. And that is to create a reliable connection and maintain the connection. Well, creating the connection is only one point, maintaining it is another. So throughout the years, we've developed different types of protocols that we put in our managed systems that allow us to ascertain the amount of PoE that's really required and the amount of PoE that's known when we start up the process, and how we develop it or maintain it by, in a sense, surveying the connections between the cameras and the port of the switches and reestablishing it should it go down. And they're maintained in these three elements that we're talking here of intelligent power limit, transit protect, PoE, and auto checking. We'll go into it in a little bit more detail. One of the key factors here in our PoE management and the auto checking is the ability of actually putting in the IP address of the connected device. Now, once we do that into the port of the switch will communicate out to the connected device on a regular basis and say, are you alive? Are you alive? Are you alive? Are you alive? If the connection is dropped, what happens is, and it's a little bit of a complicated process, is we will have to reboot the camera. How many of you have gone out in the scenario that I spoke about before about this poor installation where we lost 2 cameras, and magically by removing the RJ45 connection and plugging it in, the camera came back online? And that's because we were reinitializing the detection pulse and restarting that sequence. Well, we can't do that at 1 o'clock in the morning, or we don't want to call somebody out at 1 o'clock in the morning to do that. So what happens is we learned how to program in that the port into our managed products to do this automatically. So if after a number of tries we see that we have no connection, what we do is we reinitialize the PoE to the camera and then test it to reconnect again. Obviously, we would have to have the camera powered up to reconnect to it, or else it wouldn't work. and that's called our auto checking system. Another thing that we put into our products, and it came out of a practical application, there was a school district down in Florida. It had 100 schools under their jurisdiction, and about 15% of their schools, they had more than 50% was PTZ cameras. And what would happen is if the power went down and came back up, all the PTZ cameras would go to their zero position for reference. In doing that, the surge was so great that it would blow up the transformer within the switch. And they had this whole, they had hundreds of blown up switches. So we also have the ability of delaying the power, PoE power, so that on our heavier draw devices, we can stagger it over a 5-minute period and maintain reliability in startup of these. And this is some more of it that we're talking about. So what is intelligent power limit? Well, I told you before about how PoE works and about the fact that we have to get that detection pulse over to the PD, the camera. And again, not trying to get more technical, but it's that resistor is 22 ohms or 22 k ohms at 1,000 feet. And in electronics, when the resistance across the cable and everything else matches, when it's all the same, you get the maximum power transfer. But how do you know that? One of the things we don't know as installers, or when we go out, we can't really judge the distance of the cable itself, or more importantly, the quality of the installation. How many twists and turns are the cable in the wall? Every twist and turn increases resistance, etc. So in most switches, you have the ability, like I said, of determining power by the source or by the connected device. It's class 2 power. It requires 7.5 watts or etc. But you don't really know the resistance of the cable. And if you don't know that, you don't really know how much power is needed. So we added a third element called intelligent power limit. An intelligent power limit will actually automatically calculate the amount of resistance that it's seeing and adjust the PoE power source to provide the power that's required. We also increased the amount of power in our ports, excuse me, what we call normal 802.3 AF or AT to 36 watts. Why did we do that? Well, in our evaluation and our assessment early on about why products were shutting down, we found out that the surge element in most cameras is about 20%. So, and 20% takes us up to the limit of what we can do on normal Cat5 cabling, safely, that is. So 30 times 20% of that is 36 watts. So by providing 36 watts, we have that extra insurance in the bank that when those surges occur, we can provide the adequate power and avoid shutdowns and avoid service calls. So how does everything work together? And this is a general overview. So we set up intelligent power limit within the switch. When we start up, there may be a surge, so we have another element called transit protect. Transit protect, it actually has the built-in intelligence to determine, do I have a short or do I just need more power? If it determines that it's a short, it will shut down like anything else within the IEEE standard. But if it determines that it's just a surge, it will reach into the bank and take that extra 20% out and provide it to get an adequate connection. Lots of cameras do surge on startup. And if the power is marginal, it'll shut down. If we're in operation, then we have the auto check feature. And if we find out that we lose the connection within the auto check feature, we can automatically reestablish it. So you see how when we develop something, we don't just develop one thing, we develop something that works in conjunction to increase the reliability of the system. Here's another thing that came into play recently. About 2 years ago, we were into an installation, or our dealers were into an installation, and a camera, I'm not going to name the camera manufacturer because we do a lot of pro bono work for a lot of camera manufacturers, got a shipment of about 100 cameras, same model number. 50% of them went online and worked perfectly. 50% of them didn't. What we found out is that at that time, there was an increasing number of what we call, again, these accessory features coming online. And manufacturers were changing their firmware in order to accommodate these. Well, they affected how PoE was detected. So we actually developed a little dongle module that would overcome that and assure a good startup operation. So what was happening, and this is one of the elements again of PoE, when the PoE detection voltage is applied, it's not a spike, it's a ramp. So it can start up, and this is where we get, gee, I saw my camera come online and then it quickly dropped off. It's this ramping that happens. So the PoE starts up and starts up certain elements within the camera, but reaches a point where it exceeds the level of power provided by the port. And then, oh no, we're in a short situation. And again, because of the IEEE safety features, shuts down. Well, this dongle prevents that from happening. And as more and more manufacturers have changed their firmware, in fact, I had an incident about this yesterday, uh, they don't necessarily tell you which of the cameras you're receiving have this changed firmware. So this has been a lifesaver. And lots of times, even though, we have dealers that work through distribution, if somebody's out on an installation, it's inexpensive enough, we'll just ship it out to them. We, like I said, we work very closely with manufacturers, and we are a primary partner of Access Communications, somebody who I'm sure you've heard about. And in fact, during the startup of our IPPoE division, we actually took our products, our initial products, out to be tested. We do a lot of offsite testing, and because Access said you couldn't do what we said we could do, and 3 weeks later we got a letter of certification from them. And since then, we've worked very closely on them, particularly in the powering of their Q60 cameras. And we've created all sorts of devices that now are relatively standard in the industry that can power cameras way above the AT environment into all the way into BT. And so we've worked very, very closely, and we work very closely on Access systems in order to provide them with solutions. So one of the things they had asked for years ago is they said, we have a lot of coax out there. And, coax has this significant limitation that it's a 2-wire solution and can only work up to about 36, 37 watts and only has a distance problem. But we're replacing analog cameras. But these analog cameras have a power source in the form of DC or AC 12 or 24 volts. So we created a device that could go out where the camera is, take the 12 or 24 volt source, convert it into 60 watts for PoE compliant power, and actually transmit up to 5,000 feet over coax. Now, in a parking lot or something, you very rarely have these, but this is a drop-in solution, and we did it so it could actually fit in certain arms and certain enclosures so that it could be weatherproof within the enclosure. But this is another example of how we respond to these needs. In fact, Vigitron also has an OEM division. We don't OEM our commercial products, but we actually build a lot of modules for manufacturers that you know very well. So we were talking about data handling before, and we were talking about this pixelization situation that occurs. And one of the reasons it occurs is something you might not know, but in standard network switches at 100 megabps, and most of them are run in the automatic mode, you are limited to a packet size. What do we call a packet? A packet is essentially a video frame of 1518 bytes. Now, what does 1518 bytes mean? Basically, if you're lucky, it's a 2 megapixel camera. How many cameras today are 5, 10, 33 megapixels? Well, if you're blocked at 1518 and you're trying to put through a 33 megapixel camera packet size, you're going to have a problem. So what Vigitron did was it created network switches that allow you to program the packet size all the way up to 9,600 bytes, and in fact, on our newest one, 14,000 bytes, in order to allow you to do this. Now you're going to say, wait a minute, Neil, when I read a specification for a switch, it always says jumbo frames. Yes, it does. Jumbo frames are the norm for 1G ports. But in networking, you cannot run 100 megabps camera output, which is the standard for like 99% of the cameras out there, into a 1G port. you get asynchronous operation and you drop packets. So when I plug my 100 megabps port into the switch running in auto, it's going to run at 100 megabps. And I apologize for the dogs barking. It's going to run at 100 megabps, and it's going to have this limitation of 15, 18 bytes. So the higher the packet size is, the more we're going to get this pixelization and distortion or defocusing that I spoke about before. That's only one. We often forget that the switch itself is its own internal network. How so? Well, this gives you the ability of plugging a camera into port 1 and plugging your laptop into port 26 or port 24, whatever the uplink is, and seeing the camera. It has its own internal network, and that internal network has many names. We call it the switch fabric. And in order to see video, that switch fabric has to be 2 times the sum of the highest bandwidth of all the ports. Again, this is another piece of the puzzle that has no standards. There is no IEEE standard for this at all. So what happens is, if you don't, you get blocking in the system. So this is what happens. A camera comes in at 100 megabps. Let's say it passes the port, but we have lots of cameras coming in. Well, that switch fabric can only handle so much. And depending upon the traffic on that switch fabric, it will either pass that particular camera or not at any particular time. And that's what results in seeing it or not seeing it. So again, we have 2 considerations in our selection of and problems that could be caused by network switches that are unspecified. One is the ability of setting higher pixel standards within 100 megabps transmission. That'll take care of pixelization. And by the way, I know that some of these slides are wordy, but that's because, as you'll know, we will give out this presentation at the end of it if you so desire. In fact, a longer copy of it, but we like these to be freestanding presentations so that you can refer to it. And so again, we go into more detail about what the switch fabric is. Please take this into consideration, because it's extremely important about the switch fabric being 2 times the sum of the highest bandwidth of all the ports. How is this synonymous? Well, I often refer to it as a highway. Why do I say a highway? Well, let's say you get on a highway and you're cruising down the highway at 75 miles an hour and everything's fine. Now more cars come on the highway and you start slowing down and slowing down. Now all of a sudden you're in a traffic jam, and the exit you have to get off of is about a mile down the road. Well, believe it or not, that's very synonymous to how our video networks work, because your NVR and your VMS system will actually call to the camera to come off the exit. And if your camera is stuck in a traffic jam on the switch fabric, it can't come off. Now, the volume of cameras changes all the time, just as the volume of traffic changes on a particular, on a network. And so that will either block the car or the frame from coming out, or let it pass. And this is why it seems to be intermittent. Well, if the camera is intermittent, it must be defective. So again, we get that back and forth of sending it back to the manufacturer only to find out nothing's wrong with it. I cannot emphasize enough just how important cabling is to the success of your system, and how much we don't really know about the cabling when we go out to an installation. So within our products, and especially within another group of products that we make, mid-spans that specifically provide PoE, we've put in many features into it that allow us to overcome those higher resistance and cabling problems, yet maintaining safety within the system. Safety and reliability is always what we do. So in this slide, we basically go over, and again, I'm not going to read these, but some of the things and features that we put in through our development of our managed products in order to overcome these problems and how they overcome them. One of the other areas that's grown significantly over the years has been security. Well, we focused on that in our managed products too. So we have a 5-step security process depending upon which managed products we're talking about. The first is web managed filtering. In some cases, security networks, not often, but they're tied to the internet and they're tied to outside things. So a guard may do Amazon shopping while he's supposed to be on duty. Well, we have port 80 blockers that block access to that. TCP is the main method of communicating with the network, and it's bidirectional communication, but it's also a big delay in it. So when we talk about a camera communicating in a security system, it uses UDP, which is a non-checking one-way path. We can actually designate a port, and in doing so, we cut down on the ability of actually attacking it. MAC binding is something that's common in almost every switch, and it basically says we're going to take the MAC address of the product, which is its serial number, and bind it to a particular port and only allow these numbers, usually about 3 MAC addresses, to be allowed. However, we were working many years ago on a very, very large national contract with a very well-known retailer, and he said, we got a problem now. We have a process called ghosting, which you may have heard of, where people can emulate the MAC address and thereby actually attack the port, making the system believe it actually is that connected device. So we created our own feature, our own firmware called SecurePort. And SecurePort can actually detect when ghosting occurs, shut down the port, and alert you that it's happening. In our newer versions, we've added on top of that certification. So you can actually tie or create a certificate to the switch, to the individual device, so that it only connects or will only be recognized by the client that you say has permission to access that certificate. Another overlooked feature or function of network switching or any enclosed device is what's called the PoE budget versus the total power. Too many times a switch will have its overall power. Well, switches were not designed to run their PoE at 100% for all the ports. I mean, think of it. We have this very small device that's 1.75 inches, and as it heats up inside, it becomes a convection oven. So there always must be a safety factor between the total operating power, which is never allocated 100% to the PoE budget, and the PoE budget. If not, what happens? Well, your interior of the product becomes very hot. The heat dries out the components, reduces the reliability of the switch and its lifespan. In some cases, which it has, we're not going to name names, has caught on fire. Vigitron always maintains a 25% differential between total power and PoE budget. And for your own edification, if you're ever involved with any switch from any manufacturer and they only give you one power supply figure, please times that by 0.75 and use that as your PoE budget. It's for your own safety and reliability of the product. So what have we done over the course of this so far? Well, we've covered about cameras not powering up, cameras going offline, intermittency, cable installation, cameras disappearing, and blurry or pixelization. All of these things, again, through the process of inter-operational testing, we have designed our equipment to overcome. If you decide that you want a copy of this, this is probably one of the most important slides in the entire presentation. Networks are interactive. Networks depend on a lot of factors. We've spoken about certain things here, such as cabling, and emphasized it. When we consider the design of a network, we never ever consider one factor. In fact, the worst thing you can do, and please, I advise you against it, don't ever call up a manufacturer about any component in the network and say, well, I need an extender, I need a repeater, give me a model number. Because I guarantee you what you get will probably fail about 90% of the time. Everything in the network must be taken into consideration. So when we do an analysis of what's required in a particular installation, we take all of these things into account. And we have strict instructions within our company never to respond with a model number. And sometimes people get irritated, like, why do you need this information? Just give me the model number for an extender. Just give me the model number for a repeater. No. What's your camera? What's your length of cable? What's your PoE source? We want to make sure that the equipment that we provide is going to be reliable, that that dealer who eventually, pardon me, installs it is not going to have service calls. Okay. And so we take great lengths into asking all these questions, even if it's one particular product that we're talking about. So every part of the system matters. Every part of the system and any change in the system changes the entire complexity of that network and affects the reliability of that system to perform. One of the things that we do that nobody else does is we are the only manufacturer that makes every single type of product. We have over 200, we're actually approaching 250 products now that cover every single category within the network environment. So we are the only manufacturer that can provide a complete network solution specifically designed for your application. And most often we can give you 2, 3, or even 4 alternatives and explain what those alternatives are. What's the real advantage of that? Lack of finger pointing. How frustrating is it to have different components from different manufacturers in your system and call up one and have them just blame the other? We don't do that. Okay. So you can get everything from us completely designed for your application and avoid the difficulties, the time wasting in finger pointing. This is probably our most important product, and it's not a product. Under the pre-sales environment, we have a team of engineers. Because of all the unique qualities of a network, how uniquely it is defined by your application, you cannot do this by a computer program or a drop-down menu. We have a team of engineers called the Design Center who will work with you to design a network specifically for your application, increasing reliability, getting you the product that you need. Even if we're not providing everything, we won't make comments about other manufacturers, but we'll tell you what is required to interface and make it work. You can't do this without real people. We provide the service to anybody. It's free. There's absolutely no obligation. We don't even put any restriction on the size. We'll do it for a 2-camera. We worked on one project that was over $3 million of our products that had over 11,000 channels in it. It does not matter. The important thing is to give you reliable solutions. And again, solutions, not a solution, so that you have a choice in what you do. So the Design Center factor is used extensively, and we're very, very proud of it. As I said before, we don't abandon you when you're out on the job. If you call, so many factors you don't know until you actually get out on the job. We will work with you. We will try to find and solve problems while you're at the installation itself. And if it's affordable or necessary, maybe ship you a little dongle or something to help you at the location itself. And one of the reasons after that is our warranty. We are the actual manufacturer. We're headquartered again in San Diego, California. We do have offices throughout the world. But our warranty is production lifetime plus 3 years. What does that mean? Because I'm sure you've heard the comment production lifetime. Well, if I'm OEMing a product, then I can give you the warranty while it's in production, but I don't control the production. We control the production. And so not only can we give you a full warranty during the time that the product is active, but even when it goes end of life, we maintain a full warranty for a period of 3 years without exception. That's important. So anything in our product line is covered by this lifetime warranty plus 3 years. We tried, this is a testimonial by a dealer, one of our dealers. Unfortunately, we can't play the audio on it, but if I send this out to you, you'll be able to do it. Want to give you an example again of, and I'll go back to Access Communications. This is a picture of the Access AEC. I don't know if all of you are familiar with the fact that around the country, around the world, Access has a lot of experience, what they call Access Experience Centers. And they were having a very significant problem in their networking. They have hundreds of different components on their network, ranging from cameras, ranging from access control, audio, etc., and their network was not working. Well, we worked with them. We ascertained their problem on the network, what needed to be done, and we were selected to redo their network. Again, we don't redo it, we just provide the equipment. But in this case, we ascertained what was needed for their PoE requirements, how the network had to be laid out, what was necessary for their bandwidth, etc. We It was a very large sale of our equipment. Guess what? The installation went in and it was perfect, absolutely perfect. So, but we did not sell them or recommend products until we had a complete evaluation of what their needs were and what their existing structure was. Like I said, we're very, very proud of education. We don't try to push product, we try to educate. And we have many, many educational materials that we're happy to share with you. We have a YouTube channel, and in fact, about 2 months ago, we completed an 8 series webinar series covering many of the things that I spoke about in very great detail, and it's posted on YouTube. We have so what we call solution or application booklets. Again, they don't push product, they educate you. We believe that a more educated you is a better customer. And so what we're offering is, if you want to contact us, we will contact you after this, and we will tell you, we will send you a copy of actually a longer copy of this presentation if you want to download it. We also, we've been talking about hardware, but we also create software. We're very into health monitoring, and we have a lot of features. And we have a program called NetObserver, which is a network health monitoring software system. It can actually access up to 240,000 ports. It has lots of features. The webinar itself in it would be over an hour. But we have what's called a FreeRun program. And the FreeRun program has a built-in database, so you can actually demonstrate most of the features without having a network connection or without connecting to devices. We're happy to share that with you at no charge. So again, a copy of this, a chance to be on our mailing list to know when these application solution booklets come out, a visit to our YouTube channel, and all of that is available to you. How do you get this information? Well, this is all the contacts. Your best contact is support@vigitron.com for any of the general questions you have. My name, as Michael said, is Neil Heller, and you see my email address of nheller@vigitron.com along with my phone number. Obviously, because of the COVID situation, I will be here, and I haven't traveled in quite some time, so you won't call me and wake me up in Europe or the Middle East or Asia or any place else. So I welcome your direct contacts, and I will be contacting you once I get the mailing list for Michael. So with that, I'd like to thank you for your time and your patience, and hopefully you've gained something of recognizing some common problems that you have experienced in the network and some solutions on this. And I'll open it up for any questions now.